Hi, my name is Bahir and I'm doing the EECS 1011 bonus project. So this is my Grove beginner kit. And here is my light sensor, which I connected to the rotatory potentiometer. And here's my buzzer, which gives me the alarm, and I connected to the D5. And also this is my LED, which I connected this to the part of the D2. So here's my setup for light bus guard project. So explanation of the coding part. So I code all these parts. The beginning parts is where I clear, so everything should be clear at the beginning. And then I used A equal Arduino, so I used Arduino COM3 using the computer. And then I plugged all these numbers: threshold equal 300, height 3 equal 50, sample interval equal 0.1, plot duration equal 30, buzzer frequency equal 2000. So all gives us the helping us with the finding our helping us with the project. And this is the graphing part, which I use all these to label everything in our graph. And the most important part in my graphing is why I use high traces. High traces is the important part. So the reason why we use this high traces is without high traces, the LED would rapidly turn on and off near the threshold. Like for example, when the threshold is between 299 to 301, it will automatically gives on and off and on and off, which gives a lot of false alarm. And to keep our system stable, that's why we use high traces. And the else part of the coding is stop alarm when LED turns on. So we set this to stop when the LED is turned on, and also when the LED is turned off, it was start the buzzer or the ringtone. I'll show you later. So in the middle part is that we said that light value should be bigger than threshold plus high traces when it gives us the LED will gives us off, and when the light value is smaller than threshold plus high traces, then LED would be off. So time to run my experiment. The graph will pop on in here, so that then we know that my room light is in between 600 to 700. Now if I put my hands on top of the sensor, the light will actually goes down, and if I put my hand more and cover the sensor fully, the graph will go under the 300. So as we can see, if I put my hands back and if I pull my hand up, and if the sensor see the darkness, the alarm will beep up. And so other part that we see is why we use high traces. Now when the sensor, if you see the graph is in between to 290 to 310, there's no alarm sound, which we that's why we prevent from the false alarm. When it goes under the 250 and it goes upper the 350, it will give the alarm. That's why we use this high traces. So my learning outcome from this project was that I learned how to make the system smart. It doesn't just turn on and off at one light level. It waits until it's definitely dark below 250 to turn on and definitely bright above 350 to turn off. This prevents flickering, just like how our home thermostat doesn't consistently to turn the AC on and off. And I also learned how to talk to the more with the hardware and how to use the MATLAB and our Arduino together to work on the sensor that it has. And also one more other important thing, that handling real world problems, like the real sensor aren't perfect, just jump around a bit. I learned tricks like taking multiple reading and averaging them, adding some delays to avoid false alarms, making the system ignore tiny light changes. In conclusion, this project helped me learn more about the Arduino kit, like such the sensor part, light sensor, alarm, and other things. And also in coding, I learned how to code such kind of thing like light bus guard, which actually was a fun and interesting project, which I learned about how the function of high traces is, and how the alarm system are coded, and stuff like this. And I hope to do similar things next semester in Java. Thank you for watching.